Chapter 3.1, Statements, Negations, and Quantified Statements. In Chapter 3, you're probably going to feel more like you're in an English class than a math class, which might be a nice break for some of you. Okay, history is filled with bad predictions. Here are examples of statements that turned out to be notoriously false. Television won't be able to hold on to any market. People will soon get tired of staring at a plywood box every night. The actual building of roads devoted to motor cars will not occur in the future. Everything that can be invented has been invented as of 1899. Interesting. The abdomen, the chest, and the brain will forever be shut from the intrusion of the wise and humane surgeon. And we don't like their sound, and guitar music is on the way out. That was the Decca Recording Company rejecting the Beatles. So understanding that these statements are false enables us to negate each statement mentally and, with the assistance of historical perspective, obtain a truth statement. We begin our study of logic by looking at statements and their negations. In logic, we're concerned solely with statements. So, a statement is a sentence that is either true or false. In logic, we use lowercase letters, such as P, Q, R, S, to represent statements. For example, here we'd say, let's let P represent the statement, I teach English, and Q represent the statement, I have a dog. Therefore, we don't have to, as we're trying to evaluate these statements, we don't have to keep writing over and over, I teach English or I have a dog. Now, the negation of a true statement is a false statement, and the negation of a false statement is a true statement. Okay, so I teach English is a false statement, and the negation symbol looks like this. It's the little tilde. So I could say not P to represent I do not teach English, which is now a true statement. I have a dog is a true statement, but if I wanted to negate it, instead of having to write out the words, I do not have a dog, I can simply use my tilde or not Q, meaning the negation of this statement. In English, we frequently encounter statements containing the words all, some, or no. These words are called quantifiers, and a statement that contains these words is called a quantified statement. So using our knowledge of the English language, we can express each of these quantified statements in two equivalent ways. That is, in two ways that have exactly the same meaning. And these equivalent statements are shown in this table. There are going to be several tables to organize the ideas in Chapter 3, and so I've put them all in one page for you in your Canvas classroom. If you go in and look under the course documents, you'll see a document labeled something like Chapter 3 tables. That way, when you're studying and doing your homework, you can use these tables to help you keep everything straight. You will not be able to use the tables on an exam, though, just for studying purposes. Okay, so our first quantified statement is all A or B. An equivalent way to say that is there are no A that are not B. For example, if all poets are writers, you're saying the exact same thing if you say there are no poets that are not writers. Notice the double negative here, no, not. Remember, a negative is a positive. So all poets are writers, no poets are not writers, saying the same thing. Some A are B. An equivalent way to say that is there exists at least one A that is B. So some people are bigots is the same as saying at least one person is a bigot. No A or B can be expressed equivalently by all A or not B. Notice one negative, one negative. Right? No common colds are fatal. is the same as saying all common colds are not fatal. Some A are not B, not all A are B. Right? One negative, one negative. Some students do not work hard is the same as saying not all students work hard. Okay, forming the negation of a quantified statement can be a bit tricky. Okay, suppose we want to negate the statement, all dogs are black, right? All dogs are black. That is a false statement. Okay, so most people jump to the conclusion, well, let's say no dogs are black. But wait a minute, no dogs are black is also a false statement. They don't negate each other. Remember, a negation must have the opposite truth value. Okay, so instead, the negation of all A or B is some A or not B. Now here's my negative, but I don't want to say no A or B, just some A or not B. So likewise, the negation of some A or not B is all A or B. Notice if I said all dogs are black, that's false. But if I said some dogs are not black, that's true. That's the negation. And the negation of some A or B is no A or B. Likewise, the negation of no A or B is some A or B. And the negations of the quantified statements are summarized in this table. So all A or B's negation is some A or not B. Here's an example. All people are honest. Okay, that's not true. False. Some people are not honest. True. Those statements negate each other. Some A or B, negation is no A or B. So some roads are open. If that's true, that some roads are open, then the statement no roads are open is false. Right? If it's false that some roads are open, the statement no roads are open is true. Right? Notice how those do negate each other. So you might think of a little diagram that helps some students is to put your quantifiers up here, all, no, some, and some not, and alternating ones negate each other. Okay, and one of them, remember, has to have a form of a negative, so that's why all goes with some not. And since I have a negative in the no, I don't want a negative in the negation statement. So no's negation is just some are. There's an interesting example, I think, in your textbook that tells what it means to be simultaneously true and false, like in the definition of a statement. Right? It's got to be a complete sentence, and it cannot be simultaneously true and false. Here we go. In the television series Star Trek, the crew of the Enterprise is held captive by an evil computer. The crew escapes after one of them tells the computer, "I am lying to you." If he says that he is lying, and he is lying, then he isn't lying. But consider this. If he says that he is lying, and he isn't lying, then he is lying. The sentence, "I am lying to you," is not a statement because it is true and false simultaneously. Thinking about this sentence destroys the computer, and therefore I assume saves the crew of the Enterprise. Okay, let's look at some homework problems and see if we can work our way through them. Determine whether or not each of the following sentences are statements. On January 20th, 2013, Mitt Romney became America's 45th president. That is a statement. Yes, it is. Doesn't have to be true, right, to be a statement. It's just got to be a complete sentence, which it is, and it has to be either true or false. Take the most interesting classes you can find. That's a sentence, but it's not either true or false. That is not a statement. All U.S. presidents with beards have been Republicans. What do you think? Is it a statement? Right, it's a complete sentence, and it's either true or false. And we may not even know if it's true or false, but it can be determined to be either true or false. So what about this one? Is the unexamined life worth living? Nope, you're right. It's not even a sentence, so it doesn't meet that first criterion for being a statement, which must be a complete sentence. Form the negation of each of the following statements. Okay, it is raining's negation would simply be, it is not raining. Facts do not cease to exist because they are ignored. So the negation of that would be facts do, or simply facts cease to exist because they are ignored. Okay. It is not true that Albert Einstein was offered the presidency of Israel. Well, let's just say Albert Einstein was offered the presidency of Israel, and we have the negation of that statement. By the way, true statement there, in case you're wondering. So interesting facts in this course here. Okay, what about this one? Let P, Q, R, and S represent the following statements. One works hard. One does not succeed. The temperature outside is not freezing. It is not true that the heater is working. Express each of the following statements symbolically. Okay, one does not work hard. Well, P is one works hard, so I want one does not work hard, or not P. One does not succeed. Okay, Q is one does, oh wait, my number 2 is one does not succeed, and Q is one does not succeed, so how do I write that? Q. Okay, the temperature outside is freezing. R is the temperature outside is not freezing, so it's the negation of this, so I'd say not R. The heater is working. It is not true that the heater is working, so we would say not S. I need to negate this S statement. Express the following quantified statements in an equivalent way and write its negation. Let's do the equivalent way first. So all whales are mammals. An equivalent way to write that is there are no whales that are not mammals. Some thieves are not criminals. Okay, some thieves are not criminals can be stated equivalently by saying not all thieves are criminals. So not all thieves are criminals. No Democratic presidents have been impeached. How about all Democratic presidents have not been impeached? And finally, not all parrots are pets. How about some parrots are not pets? Some parrots are not pets. I'm going to change colors over here so we can write our negations in red. So our negation for all whales are mammals, I've got the all, so I need my negation, and they're all and no is negated with some, but I need the some not for all, so some whales are not mammals. Some whales are not mammals. Some thieves are not criminals. Well, we just wrote the negation up here. Some whales are not mammals. I have some thieves are not criminals, meaning that negation must be all thieves are criminals. No Democratic presidents have been impeached. So here I need my some without the not. So how about some Democratic presidents have been impeached? And finally, not all parrots are pets. Now look at this one. This is in our standard form of all, some, or no. So I may want to think about the equivalent way to write it, which gets me in my some parrots are not pets. Oh, when I see some are not, I know that the negation is all are, right? So all parrots are pets. Okay, and I again apologize for the penmanship. Okay, one more. Let's look at this. The following diagrams show relationships between two sets. Note that these diagrams are just like the Venn diagram studied in Chapter 2. However, the circles are not enclosed in a rectangle representing a universal set. So use each diagram to write a statement beginning with the word all, some, or no that illustrates the relationship. Then determine if the statement is true or false. If it's false, write its negation. Since this circle is completely enclosed in this circle, that is representing that all birds are parrots. All birds are parrots. Is that true? No, that's false. All birds are not parrots. So to negate that, I would say some birds are not parrots, right? Some birds are not parrots. These circles indicate there's no overlap there. This is telling me that no college students are business majors. No college students are business majors. Now, that's also false. So to negate no are, I need that some are. So the negation would be some college students are business majors. Okay, I believe that finishes up Chapter 3.1. You'll see how you do on your homework. Let me know if you need anything.